Karibu SolidWorks Tanzania. Natumaini umekuwa na lesson poa sana ya 3D lesson 1 and lesson 2. And now we're here for 3D lesson 3. So on lesson 1 tuliangalia kuhusu uchaguzi wa planes like kama ni front plane, top plane and right plane. Lakini pia tuliangalia namna ya kufanya extruded bows na revolved bows. Then on 3D lesson 2 tuliangalia kuhusu swept bows au bays, tukaangalia kuhusu lofted bows au bays, lakini pia tukaangalia kuhusu extruded cut, hole wizard na revolved cut. Okay, so this was the final feature ambao firstly tuliichora kwa revolved cut, lakini secondly tukaichora kwa revolved base. So here yote ni kukuonyesha kwamba there is no one trick of drawing, like kuchora inatakiwa tuelewe how things work. Hautaki kukariri kwamba okay, to make a bowl like this you need to revolve, but you can do a number of other procedures to come into this ball. For example, initially tulichora revolve ya semi ball, alafu tukaifanya revolve cut, but secondly tukafanya revolve just one feature and then we ended up here. Okay, so today tutaendelea na swept cut, then so we won't do lofted cut because it's just like loft except yenyewe inafanya cutting ni similar tuseme revolve. So kwenye revolve base ilikuwa inafanya revolve of a solid feature, lakini revolve cut ikawa natumia the same way of revolving but for cutting. So similarly to swept cut, it means inafanya the same as sweeping, but here we are doing sweep cut rather, right? Okay, so we will do swept cut and you will do the lofted cut. Okay, you will try to do that. Procedure ni zile zile. Maybe utakuwa na feature ambayo umeichora kwa kuloft kama vile kile kiti ambacho tuliloft with 3 cycles, and then unaweza ukafanya lofted cut. Okay, in the same manner by using planes, unaweka plane tofauti alafu unafanya hiyo feature, right? Okay, so let me delete this. So right click here, click delete, enter, click here, then right click, delete this sketch 2. Okay, so we want to do swept cut, so lazima tuwe na feature ambayo tumesweep. So lazima sana iwe swept feature, lakini mara nyingi kama tunafanya swept cut, tunafanya swept cut kwenye feature ambayo tumeifanyia sweeping. So let's create a pipe. So let's say top plane sketch, right? Let's sketch. It's good to nilisema before ni vizuri uka sketch from the center here, from exactly this XY center, ili hata unapokuja kutengeneza other features on top of it. Let's say creating a path. This is a profile. Creating a path, unaanzia pia exactly at that center, ndo usio ume diverge from this exact center of this feature. So let's say smart dimension. Say this is 30, then check, save this one. Then we go to, let's say that was top plane, so let's say front plane sketch, let's say normal to that front plane, and let's create our path here. So let's create our path using, let's say, 3-point arc. So from here to here to here. Okay, check. Okay, save. So now here we can come to features and say swept bows. We create first a swept bows feature. So profile, this is the profile. You'll see this, the path was already selected automatically. But if you delete this, you can just select it manually here. So ilikuwa iko selected automatically. So instead of kwa mfano, if here we want a hollow pipe of this diameter, then we will say thin feature, right? Thin feature, and then we will give it a thickness of, let's say, 1 or etc. Thickness of that pipe. I think you saw that earlier. Lakini, let's say you want to create so check. So let's say you have swept balls feature like this, and you want to create a hole here that is not similar diameter as this. So let's say we create a smaller hole here, right? So we what we can do is we can go back to this face, right, and say sketch, okay, and then we can sketch here. Let's say no more two. We can sketch here our profile of a small hole that we want to extrude the cut. Let's say this much. Smart dimension, say this is let's say 20. Okay, yeah, say 20, right? Then save. Then we want now to create a path. So what can we do? We can go, so this one, is a front plane, right? No, it's a top plane. So this initially this cycle was drawn on a top plane, so particularly this one too is on top plane. So now we want to create a perpendicular path. So here's what we can do. We can go to front plane and say sketch, and then on a front plane now, if you say normal to, right, zoom to extend, so we can sketch our path here, but we want to make this very symmetric to use the same path. For example, here we can draw another path. You see, we can draw another path here, maybe from here to here, maybe to here. Kama tungekuwa tumeipa dimension ile path ya kwanza, ingekuwa rahisi zaidi kusema dimension, na tungekuwa na exactly the same path as the previous one. Okay, ili iwe exactly at the same time symmetric, but we can reuse the previous used sketch path. So unaweza kuja hapa kwenye sweep, uklik hii, so sketch 1 ilikuwa cycle, as you can see there, down there, but sketch 2 on sweep 1. So here is sweep 1, sweep 1, sweep 1, sketch 1 was the cycle, sketch 2 was the path. So tunaweza select sketch 2, and then what we can say is we can say convert entities. So umeona tuna reuse the same path. So okay, so now we can say features, and then here we can say, let's try to say swept balls. Let's say this to that. Yeah, that works. So Control Z. So we say on feature, we say swept cut, rather run swept both. So profile, we select this cycle as a profile. Path, we select this path as a profile. So that means we are creating a hole by sweeping, right? And then say check. So you see, we have our swept cut here that help us creating this hole. Sasa unaona hii feature ambayo tumeichora hapa chini, tungeweza tukachora feature ambayo ni, let's say, polygon, like hexagonal feature, right? Inaweza ikawa hexagonal feature, so lazima iwe circular, right? Yeah, for example here unaweza ukaja kwenye sketch 1, sketch 3, nasema edit sketch, right? Normal too. So I can just delete this. Yes, hapa unaweza ukaanza from the beginning, alafu nikachora hapa a hexagon, rather a hexagon. Smart dimension it, let's say, sorry, Control Z, smart dimension, let's say this is also 20. Okay, circumscribed in a cycle, then okay, then save. So you see, we created a hexagonal hole inside that swept feature, that pipe. So tunaweza sema front plane, tukasema section, unaweza ukaiona vizuri zaidi, then check. So you see, yes, so we have a feature like that. We used a swept cut, right? Yeah, okay. So uncheck. Yeah, so similarly hata ukienda kufanya lofted cut utafanya the same procedures, uta create more planes kama ni kwenye front plane ama ni kwenye top plane, alafu the only thing that change is instead of lofting a solid feature yenyewe itafanya lofting cut. Okay, so let me delete this one, right click, delete. Okay, delete this sketch too, delete. Okay, right. So if you remember before tulikuwa tunaweza kufanya filleting and chamfering kwenye two dimensional drawings, lakini it's also possible kufanya filleting and chamfering kwenye 3D drawing. Okay, so let's say umechora two dimensional drawing yako lakini hujaiwekea chamfer wala fillet, but let's say it's a rectangular feature but you want to put fillets to on the 3D feature my object, is also possible. So let's create here, let's say front plane. Let's create here a rectangle. So let's say we have a rectangle here, smart dimension. Let's say this is a 100 and let's say this is a 50, 100 by 50, right? So you see from this one tungeweza tuka create fillet here ama chamfer, right? So tungekuja tu hapa kwenye fillet au chamfer, tuseme sketch fillet, tuipe radius fillet tuseme labda ni 15, alafu tunge select corner point ama two lines, so here then there then check, right? Lakini pia tungeweza tuka create chamfer, so select here sketch chamfer, let's say chamfer of 15 to equal distance. I think you saw the other time, like there is equal distance, there is angle distance, there is distance. Yes. Okay, so here, or you can select lines, this line and that line instead of the corner point. And you see, so when you extrude this object, maanake utakuwa na object ambayo say extrude feature. Okay, extrude feature, extrude base. So extrude by 10, say 10, check. So you see, you have your feature here with fillets here of R at 15, but with fillets too of 15. But tungeweza tukafanya pia hivi kama tukufanya kwenye 2D. So let's say Control Z, Control Z, Control Z, Control Z. Yeah, so we have our rectangle, corner rectangle like that. So let's say features, say extrude base, say extrude by 10, then check. So now we want to do the filleting and the chamfering. So we come here, you see there is fillet. So in this arrow, you have fillet and chamfer. Then you see if you say fillet, again, here this is the radius of the fillet. So let's say 15, this is the radius of the fillet. And the fillet can be either symmetric or asymmetric, right? Mostly symmetric. And then you just click the edges. So for here, I want a fillet at this edge and that edge. You can select all edges if you want to, but these two, then check. See, but also you can do chamfer. So if you look here on fillet, you can explore more and see other kinds of fillets here and try to choose different surfaces and you see how they react. Okay, so you can choose this one and say items to fillets, or this one select three phases, 1 2 3, like let's say 1 2, lower 1 3, like this is this is phase 1, this is phase 2, this is phase 3, then it will put a fully defined curved fillet like that. I mean, you will explore that, right? Okay, so let's go to chamfer. So you click here, you select chamfer, and then you set the, so you see here automatically the chamfer is distance and angle, right? So the angle of chamfer is normally 45, and then the distance here of chamfer you can change. Let's say this is 15. Enter, and then you can select your edge. So this edge, and so that edge you can select it from, and even here, if you go here, you will see it. Yeah, or you can just go here and select it. Yeah, so chamfer, then check. So you see, again, we have the same rectangle that we chamfered and filleted after we had a 3D feature. So you can decide put chamfer before or after the features. Again, you see, initially we did patterning, but you can also do patterning on you can also do patterning on a 3D feature, right? Or 3D objects. You can also do patterning. So there is linear pattern and then there is circular pattern. So let's say we have a feature. Let's say here, say sketch, um, no more two. Let's say we have a hole. A hole is a feature. Extruded base is a feature. All are features. Let's say a hole, smart dimension. Let's say this is 10. Okay. So let's say we, instead of making, let's say we have we want 4 5 holes here along this side, along linear to this, similar to linear patterning kwenye 2 dimension. But then before, if we create a hole here na baadaye tunataka kufanya hiyo hole pia, hiyo hole feature tufanye pattern is also possible. So we can either linear pattern this and create holes, like let's say here we can go to linear sketch pattern, then we select this is the object to pattern, and you see there is a pattern along x. I think you understand kunaweza kupattern pia along y as we discussed earlier. So naweza ongeza distance between those features. Let's say this is 15, and then how many items? 2 3 4 5. Let's say here distance is 12. Okay, 5 or maybe 13. Yeah, so I have my 5 holes, I mean my 5 cycles kwenye 2 dimensional feature, and then naweza kuja extrude niseme extrude cut. Okay, so naweza ongeza hapa more value ili niwe sure kwamba that's the hole, then check. So you see you have your 5 holes linear patterned in the 2D drawing, then extruded cut. But let's say Control Z, Control Z, Control Z again. Let's say we just want to pattern in the 3D feature. So we go here and say extrude cut, sorry, and say extrude, sorry, here, and then say extrude cut. So we extrude cut that one hole. So you see we have that one hole, but then we need other 4 holes here, linear, right, along X. So we can just come here to linear sketch pattern. So in this arrow, you say linear sketch pattern, and then here, you see here, you select the feature. So this feature here is selected automatically. So I can delete this. And here in the feature, I can just come and select here, cut extrude. Or you can search it from here. You can say this one, select cut extrude. Both ways, okay? Then here, the direction of linear pattern. So if you select here, then it will go along Y. If you select this, then it go along that line. That's along X. So this one, you see here items are 6. So you can change the distance between items here to 13. Okay, like that. But items, let's say 5 items. Okay, so I don't want any items on direction Y. You can reverse directions here, but it won't make sense because there is nothing much, there's no feature on the left, so leave it on the right and then say check. So you see, we made the same linear pattern features of the holes, but this one we did it on a 3D object, right? I hope you understand it. And then we have circular pattern, but I think you understand circular patterns need a circular feature in the very beginning. Like you need to have a circular feature. Okay. So let's say here, say sketch, no more two. Let's say we have a feature like this. Okay, so let's say we have an extruded base. Okay, so you have an extruded base of like, let's say 2 millimeters, right? And then let's come here and say sketch, say normal to. Um, let's say I have a slot. All right, let's say 3 point arc slot. So this point, maybe that point, maybe this point, and then maybe here. Check. Okay. So maybe I need three of these slots circular patterned at 360 to this surface here. So I can do it in a 2D again. So let's say circular sketch pattern. So here I'll just select the center of this cycle or click this cycle. Oh, sorry. Delete. So entities to pattern. This is the entity to pattern. So it selected the center of this cycle automatically, the point one. All right. So items here, let's say three items. Minimize. Okay. Then say check. Sorry. Circular sketch pattern. So find the center of this. So the center of this. So this is not feasible. It's not visible. Um, let me do what? Let me draw. Let's say normal two. Let me draw. Let me draw another cycle. But yes, from here to here. But I'll make it construction. Escape. So I'll click this cycle and say construction geometry, right? So it's construction geometry. So then I'll come here and say circular sketch pattern. So this one I'll select this point here. Okay, this point. And then features, I'll select this slot feature. Items three, then I'll say check. Right. So nimechora hiyo construction cycle ili tu nisaidie kuona the center of this point here that I wanted to select. Initially ilikuwa hainionyeshi where to select. Then here naweza sema features, extruded cut, naweza kata through holes. Ama naweza kata to not through holes, maybe at 2 millimeter, then check. Okay, maybe I have feature like that. Okay, so you see, I made a circular pattern of a slot into three items, and then I did an extrude cut. But Control Z, Control Z, Control Z. So let's say I have a feature already. So hiyo ilikuwa ni circular pattern kwenye 2D. So if I have a feature already, so one sketch feature extrude cut by two, then here. So you see I have just one feature right there. So if I want to circular pattern this feature, I'll just come to here and say circular pattern. So here I'll select the center of this, right? So this center. Okay, and then here I'll come to features. I'll select this one, which is extrude cut. So number of features three, right? I think you can see it, right? So you see, it's okay. I selected the edge, but it knows the center of that edge is the cycle. So not necessarily to click the point, you can click the edge of the cycle. So either the edge of the cycle or the center of that cycle. Then check. So again, we have our circular patterned features. Yeah. So we have other curve driven pattern, sketch driven pattern. I think you can explore more on those. Curve driving manake unachora like a curve, alafu unachora one feature and then una select hiyo kwenye hiyo feature unaisema follow this curve. Unachora curve kama line, let's say spline, um, and then unachagua feature ambayo unataka iwe patterned along that curve ama along that the spline, right? So let's go to mirror. So mirror tunaweza kuikuta hapa kwenye pattern, lakini pia kuna mirror ambayo inajitegemea iko hapa. This two is mirror. Okay, so mirror inafanyika kwa kutumia planes. Like before tulikuwa kwenye 2D drawing tulikuwa tunafanya mirror kwa kutengeneza dashed line ama construction line ama construction geometry line. But here ukitaka ku mirror 3D feature you have to use a plane, right? So let's say now you have to know every object that is mirrored is normally inverted, like inakuwa ni true but vice versa. Like if you mirror this feature it will look like it is like this. So if you put a mirror here, this feature will look like that, like it's inverse, right? In reverse. That's how it's a reflection. Okay, but if you mirror a cycle, you won't see a difference because it's just a cycle. But if it was an open sketch, you will see it inverted. Okay, so let's say we want to mirror these holes here. So we want to mirror them to appear down here. So that means we need a plane here. So a plane there is so front plane, no. Top plane, top plane, yes. Top plane. But then you see our top plane is not exactly at the center here. Let's say right plane. So right plane is not the one. So top plane. So tukijua distance, let's say from here to here ilikuwa ni 15. So 25 is the middle. So that means if we need this, so let's say so tukifanya mirror ya this plane, these features won't happen, won't be here because the distance from here to here is almost 35, and from here to here is just 15. So, and you know, a distance from the mirrored object is the equal to the original object. So you won't mirror here perfectly. So we need a plane that is exactly at the center. So what do we do? Tutaenda kwa reference, tutasema plane, and then utaona hii plane imekuwa squeezed by 10, right? And I think by 10 that's exactly the middle of this, because this chamfer was 15 plus 10 is 25, so 25 is exactly the middle of this. So check. So you see now this plane is exactly if you say here normal 2, if you say normal 2, you will see like this plane is exactly at the center of this rectangle, not of this circle, because this circle didn't even measure where it sits. So now we can mirror. So let's say you just say mirror, and then here is a mirror face. You can select a face or a plane. Okay, a face is like this one. So if you select this face, that means you mirror it upward. So if you had a face, if you had other features here, and you select this face, you'll see it mirrored up there. But here you select a plane, say plane 1. Features to mirror, say these features and that, right? So you see there is a linear pattern. So if I delete this, yes, linear pattern is fine. So hizo feature unaweza select pia from here. Unaona kutoka hapa ukiklik hapa utaona hapa tulikuja kuwa na L pattern 1, right? Ama unaweza ka select to from here. Then ukisharizika kwamba that's what I want to mirror, then you say check. So you see you have your features mirrored down there. So ungeweza ukafanya mirror kwenye 2 dimensions, but unaweza pia ukafanya mirror kwenye 3 dimensions. For example, let's choose a right plane. This is the right plane. So let's say we want to mirror this circle and those features inside. So tunaweza tukasema okay, reference plane tukai squeeze it manually, tunaweza ivuta manually. Sorry, control Z, sorry, cancel. Say right plane, then reference, say plane, then squeeze it. Yeah, maybe there. Okay, alafu tutakuja tusema mirror, then plane tuna select this plane, alafu tunakuja kwenye features tuna select so this feature kulikuwa kuna extruded base na extruded cut, so unaweza ka click hii, so yes, so not the face actually, delete. So we want features. So here, so we want this boss extrude, we want this cut extrude, and this, yes. So boss extrude of this cycle, cut extrude of this slot, and the circular pattern, and then check. So you see. So you see in the mirror, this object here is inverted, is this one here. And this object here on the original is this object here on the mirror. And this here on the original is this here on the mirror. So you see this is inverted or reversed or negative, but it's exactly at the same distance from the mirror to here and from the mirror to here. Okay, so I hope umeelewa pia kuhusu kufanya mirror. Right, so rib and draft, those are not very essential features. Ni feature ambazo pia nadhani unaweza ukaziona kwenye extrude base ama extrude boss. So let me delete this, delete from here. Right click, say delete. Okay, delete these planes too, and this one too. Okay, and this sketch too. So draft, what's drafting? So let's say front view sketch, chukua corner rectangle, let's say here, let's say we have a square, let's say here is 35, and let's say here is also 35. Okay, enter. Then features, let's say extrude base. So let's say you extrude by 35 again, but you see this is a flat extrude, but you can draft it inward or outward. So you see, if you say draft, you see there is a degree here, and you will see when I increase the value here, you see this is drafting inward. Okay, you can have a feature and you can say save. So you see we have our feature, but we drafted it inward. We have like a concave feature or or convex on the other direction. But we could also draft outward. So edit feature. So in drafting here, we say draft outward. So you click this, you check this button, this icon, draft outward. And you see from the original feature, we diverge. The other one, draft inward is converging, draft outward is diverging. Then you see you have a feature like that, which we drafted outwards, right? Yeah, so edit feature, so we can remove the drafting. So here the angle here should be just one, check, right? So that's what draft do. Okay, so you see here it's a neutral plane, so I say this is a neutral plane, and then this is a faces to draft. So faces to draft, right? Okay, yeah, so I think you will explore more on drafting, although as I said earlier, you can just do drafting on on a extruded base or boss, you can draft inward or outward. So it's not really necessary to use this draft icon here or the rib too. So it's not really necessary, but you can search on that and see how it works. So the other one here is shelling. Yeah, so shelling inakusaidia kutengeneza kitu kama draw, right? It takes like it leaves your feature with only one closed surface. Every other surface inakuwa shelled away. Okay, inakuwa kama drawer. So ukiclick shell, so hapa ukiselect face, let's say this face, thickness of shell here, let's say 10. No, let's say 2. So you can say show preview. So you see this, we are shelling inward. So that means this whole part, tuna remove all of this. Check. So you see, this is shelling. Inamaanisha everything left outward is what we dimensioned. So say here, edit feature, we said it's 2. But you can also shell outward. If you shell outward, then this box becomes the open surface, and then it gives an extra thickness outward of the value that you set here, and then say check. Okay, so the surface that you choose, that's the direction of shelling. For example, if we delete this shell, delete, if we select this surface as shelling surface, this will be the open surface, and this one will be the closed surface, right? So say shell, click shell, select surface, show preview, and then check. You see, so this surface we selected is one that will be the open surface, and then the opposing one will be the opposing one will be the closed surface. Yeah. Okay. um so you can shell any feature, not necessarily a box like this. So let's draw like a closed cylinder. Let's draw a solid cylinder and see if we can make like a bucket from it. So top plane, sketch, cycle. See a cycle here of let's say 50, enter. Then features, let's say extrude base, let's extrude it by 50, enter, check. Right, let's say we want a bucket from this, so we can just say shell, select this surface, show preview, then we say check, and here we have it. Yeah, yeah, I hope umeelewa kuhusu shelling. Okay, so wrapping, intersect, we will see it when we do some examples, or we do some design here and there. We'll see how to do the wrapping, how to intersect features, etc. So here you see we have curves. Okay, the best feature here that is used most commonly is helix and spiral, right? Helix and spiral. So let me delete this, delete this one to delete. So if you want to have a helix and spiral, first you have to draw a cycle, a starting cycle. So let's say top plane, sketch, cycle, here, smart dimension. Let's say this is 30, and then let's say isometric. So now we can go to features and say curves and say helix and spiral. So you see it has already started like a helix or spiral here. So you can just say pitch and revolution or height and revolution, etc. So let's say pitch and revolution. So what's the pitch? So pitch of the spiral, let's say the pitch is like 3. Let's say 3 is the pitch. 3. 3 is the pitch. All right, and here you can add your revolutions. You can just hold here and you see, add your revolutions. Starting angle, you can just say 0 starting angle, right? It can be 0 starting angle, and then you can say check. See, and once you have your spiral like this, you can create a spring from here. Yeah, and sorry, to create a spring from here, you can just come to swept balls and say circular profile. So you see you have sketch profile where we selected profile and the path, just say circular profile. Okay, and path, this is the path. Let's see if it misbehaves, and if this collapse here, I think we will see it the other time, but I hope you understood a lot. um Sorry. um I see it's not doing what I wanted to do. So uh let's say, um let me delete this. Right click, say delete. Okay, let's say from here, let's say swept boss, let's say circular profile, let's select this circle. Yeah, okay, and say this is 2. Okay, okay, yeah, you can hide this. Okay, so this is like a bango, ini kama bangili, right? Yeah, yeah. Okay, let's try. Let me delete that. Let me delete that too. So let's say top plane, sketch a cycle here. Smart dimension. This is, let's say, 30. Enter. Then features. Let's say helix and spiral. Right. Okay. Let's say want a swept boss, circular profile. Okay. Okay. I think if it's not responding here to create like a spring, we will recap on this and we will look again at this creating a spring feature on the coming lesson. So on the coming lesson, we will. Oh, so it's here. It's here. So you see, so the spring is here. So I said circular profile and then I selected this, the path as the helix and spiral, and I said here the diameter of my spring. As you remember, pitch ilikuwa like 3. So nimeka diameter lower than the pitch so that I have like a pitch is from here to here, right? You can also say thin feature. You can make this spring of yours hollowed, right? Which is not necessary. And then say check. Yeah. So you have a spring like that, and you can select this sketch, I mean this helix, and hide it. Yeah. Yeah, I hope you understood it. So naweza irudia, naweza rudia labda ili wote tu kwenye one page. So delete. So I selected top plane, I said sketch, and I said cycle, and I selected from this center point here. And I said this dimension here is 30, enter. And then I said features, I said here I said helix and spiral. um, so I selected here pitch and revolution. The pitch is 3, revolutions are like that, starting angle 0, clockwise, then check. Then after I had this, I came to features again, and I selected swept bows, and then I said circular profile, right? Sorry if it's loading. um I think it's consuming some power. Yeah, but I think if you go back to this video what we did earlier, you will see everything clearly, that how we did it. Yeah, so good job. You are doing well. Yeah, so here's the helix and spiral. So here, this is the diameter of that cycle that we want to make a spring. So because we had a picture of the pitch of 3, so we can put here a diameter of 2, and then there we have it, and then say check. And then we can come click this spiral and hide it. So yeah, I hope you enjoyed this lesson. This will be the end of 3D drawing features. This is the final part. And so next time, kwenye next lesson, we will do some practices. We will have some 3D objects and features to redraw using the SolidWorks, so that you have more capture of how we go about having 3D features and 3D components. So until next time, I wish you nice lessons, the upcoming one and previous ones. I hope you are enjoying the journey. You are in the right direction. You're doing great. Keep pushing, and I'll see you next time. Ciao.